In this video, we're going to use related rates to solve problems involving distance. It says a street light is at the top of a pole that has a height of 9 feet. A woman 5 feet tall walks away from the pole with a speed of 4 feet per second along a straight path. How fast is the tip of her shadow moving away from the pole when she is 38 feet from the base of the pole? So we want to draw a triangle that kind of represents this scenario. So I'm going to draw this triangle, and then we're going to kind of put a line right here. That would be, let's see, the pole is 9 feet high. And then this lady is, I probably went just a little too far. This lady is 5 feet high. And this would be the tip of her shadow. So the light's coming off the top of the pole, shining this direction. It hits the top of her head and her body, and then puts a shadow on the ground that ends right here. Now, how fast is the tip of her shadow moving away from the pole when she is 38 feet from the base of the pole? Well, first of all, that's not a constant value. The only constant value we have here is this 9 feet and her 5 feet height. Those are the only two constant values. So I don't want to throw 38 feet in here right away. What I want to do is I want to write out that the distance she is from, the distance she is from the pole is x. So we're going to say that this is x here. So, and we're going to kind of label this distance right there. X goes from the pole to where she is. And then we're going to say that the distance from the tip of the shadow to the pole is a y distance. Which means the distance from this spot to this spot here would be y minus x. And then we're going to, because we're taking the large y value and subtracting out the x, that's why I got y minus x. And then we're going to use this, we're going to use similar triangles to basically get an equation that we can use to differentiate to find this change, because they're saying how fast is the tip of her shadow moving away from the pole. So we're looking for the tip of her shadow right here. We're going to call this length here. That'd probably be dy over dt is what we're looking for there. So dy over dt. Okay, let's set this up. First of all, if we look at these triangles, we got two different triangles that we're looking at. We have a triangle that is 9 feet here to the tip. I'm going to put the tip of the shadow is y. Okay? And then we also have this other triangle, which is her height, 5 feet, versus the tip, and that is y minus x. So these angles for the two triangles are the exact same, right? They share this angle here at the tip, and then they have the same angle at the 5 feet as the 9 feet, because that light is shining off there to the top of her head and then down to this spot. And then obviously a 90-degree angle here. So they share these three angles. So we have similar triangles here, and we can say that the ratio between this height and this height, so 9 feet and 5 feet, so 9 over 5, is going to equal the ratio between the y value and y minus x. So then what we need to do is we need to start kind of multiplying and solving this equation, and then do a little differentiation here. So let's multiply, cross multiply here. So we end up with, this would give 9 parentheses y minus x equal to 5y. Let's go ahead and distribute that. So we're going to get 9y minus 9x equals 5y. And then let's try and get x and y on opposite sides. So we'll move this 9y over here. We get negative 9x is equal to, subtract the 9y over, I get negative 4y. And I could drop the negative sign on both of those and just say that that is 9x is equal to 4y. Now let's take the derivative on both sides with respect to time. And when we do that, we're going to end up with 9 dx dt is equal to 4 dy dt. Okay, now they give us some information in this problem. They tell us that, let's see, a woman 5 feet tall walks away from the pole at a speed of 4 feet per second. So the woman's speed, which would be, in this case, it would be, let's see. Okay, this is the x was the distance that the woman was. Remember from the pole. So we're going to say that dx over dt, that is equal to 4 feet per second. We probably should have done that at the beginning of the problem. So that means that we have 9 times 4 feet per second here, which is equal to 4 dy dt. And we're trying to find dy dt. And dy dt, the y was the distance of the shadow from the pole, and we're trying to find that speed. So what we're going to do is we're going to divide each side by 4. So when we do that, the 4's cancel, and we're left with dy dt is equal to 9 feet per second. So the shadow is changing at a rate of 9 feet per second.